Question number 71 says find an expression for dy by dx. So first we have to find dy by dt. So dy by dt, derivative of sine t is cos t. Then we have to find the derivative of dx by dt. For this sum we have to review this again. We have to do d by dx of a power ax plus b to the power n. That means the power first, then we write this with power less than 1 into the chain rule d by dx of algebra. So by that, if we have d by dx of tan square theta, let me consider the angle to be theta. So we write the power first, then we write this thing by reducing the power by 1, and then we write d by dx of whatever is inside the power, which is tan theta. So that's how this works. So we write 2 first, then we write 2 first, then we write tan t, and then we write d by dt of whatever is inside the power, which is tan t. So we can write 2 tan t, derivative of tan t is sec squared t, and the chain rule of this angle is 1, so I'm not writing it. So this would be 2 tan t sec squared t. So therefore dy by dx is dy by dt, which is cos t divided by 2 tan t sec squared t. Now this can be further simplified. Dy by dx, of course they didn't tell us to simplify our answer. They said you need not simplify your answer, but anyway, if we simplify, if we bring the sec squared t upstairs, because of the identity 1 by cos theta is sec theta, so 1 by sec theta is cos theta. So if we do that, we can write cos t, and if you bring sec squared t upstairs, this would become cos squared t divided by 2 tan t. So we can write cos cubed t divided by 2 tan t. In question number B, find an equation of the tangent to the curve at the point t equals to pi by 4, and we have to express your answer in the form y equals to x plus b. So let's find the gradient first. At t equals to pi by 4, we have dy by dx. So cos cubed t means cos pi by 4 whole cubed divided by 2 tan pi by 4. So now cos pi by 4 means square root of 1 by root 2 whole cubed 2, and cos tan pi by 4, tan 45 degrees 1. So we can write, so 1 by root 2 whole cube means, if we simplify that, so we can write 1 by root 2 into 1 by root 2 into 1 by root 2. So that's what it means, divided by 2. So 1 by root 2 into 1 by root 2 is half into 1 by root 2 divided by 2. So this would be 1 by 4, 2 and 2 is 4, into 1 by root 2. So the gradient, we have to find the gradient of the tangent. That means gradient of the tangent and gradient of the curve is same. So we write gradient of tangent is 1 by 4 square root 2. Now we need the point. So at t equals to pi by 4, the x coordinate is tan squared t. So that means tan pi by 4 whole squared. So tan pi by 4 means 45 degrees, so tan 45 degrees 1 squared is 1. So and y equals to, so we have to take a look at y, is sine t. So sine pi by 4 means sine 45 degrees 1 by square root of 2. So equation of tangent, so the point is 1 comma 1 by square root of 2. So the equation is y minus y1 equals to m. The gradient is 1 by 4 square root of 2 x minus x1. Now we have to express the answer in the format of y equals to x plus b, so we can just write it y minus 1 by square root of 2 equals to 1 by 4 square root of 2x minus 1 by 4 square root of 2. I'm multiplying 1 by 4 square root of 2, so I can write y equals to 1 by 4 square root of 2x minus 1 by 4 square root of 2 plus 1 by square root of 2. Now this sum is actually, these calculations are nothing but simple algebra. They look a bit difficult, but they're simple algebra. Now if I take 1 by square root of 2 common from this, it becomes like this. If I take this, would be 1 by minus 1 by 4, and this would be 1. If I take minus this, if I take 1 by square root of 2 common, so by calculation 1 by 4 square root of 2x, so this would be 1 minus 1 by 4 is going to be 3 by 4. So 3 by 4 into 1 by root 2. The final question is Cartesian. Find the Cartesian equation of the curve. So the curve is x equals to tan square. Let me write it down here. So x equals to tan square t. So we have this, and y equals to sine t. So we have to convert this into Cartesian format, and it has to be y square equals to fx. In order to do this, we need some sort of an equation that will connect the two. Now from C3 you'll remember we have tan squared theta plus 1 equals to sec squared theta. So we have this connection, and there's another connection, tan theta is cos theta by sine theta. So I think it's better if we use this rule. So if we use this, we can write, we know tan squared t plus 1 equals to sec squared t. So let me plug it in tan squared t. I can just write x because tan squared t is x. So x plus 1 equals to sec squared t. Now we have sine t. Sec squared t is 1 by cos squared t. So we can write x plus 1 equals to 1 by sec squared t is the reciprocal of cos, so 1 by cos squared t, and cos squared t is 1 minus sine squared t. Another identity we are using here, so we can write x plus 1 equals to 1 by 1 minus, now sine squared t, so we know sine t is y, so sine squared t is y square. So that's what we got. Now we have to rearrange it and write y square equals to what? So let's rearrange this. So if I put this here and this here, I can write 1 minus y squared equals to 1 by x plus 1. So therefore 1 minus 1 by x plus 1, this whole thing equals to y squared. So therefore y squared equals to 1 minus 1 by x plus 1. That's the Cartesian equation. This equation is parametric equation given, and this time a sketch is also given. Now the first one is we have to find the equation of the tangent. That means we need the gradient dy by dx, and we need to find the point. So let's find the gradient first. So dy by dt, derivative of sine theta is cos theta, so the theta is t plus pi by 6, and by chain rule if I differentiate this I'll get 1, so I'm not writing it. So this is the derivative of sine theta. Now dx by dt of sine t is cos t, so derivative of sine t is cos t, d by dt of t, that the chain rule is 1, so I'm not writing it. So therefore dy by dx is dy by dt divided by dx by dt, so cos t plus pi by 6 divided by cos t. We have to find the gradient at t equals to pi by 6. So at t equals to pi by 6, dy by dx equals to cos pi by 6 plus pi by 6 divided by cos pi by 6. So we know pi by 6 is 30 degree. So 30 degree plus 30 degree is 60 degree. So cos 60 degree is going to be, if you remember this triangle, you have to memorize this triangle. This is very, very helpful. This is square root of 3, this is 1, this is 2. So cos 60 degree or pi by 3 is adjacent by hypotenuse half, and cos 30 degree or pi by 6 is adjacent by hypotenuse square root of 3 by 2. So here cos 30 plus 30 is cos 60 degree. We can write half divided by, this can be written as root 3 by 2. So that means, so the gradient is 1 by root 3. So if the gradient of the curve is 1 by root 3, gradient of tangent equals to the same 1 by root 3. Now we need the point. So at t equals to pi by 6, so we can write x equals to sine pi by 6. So x equals to sine pi by 6. Pi by 6 is 30 degree. Sine 30 degree is half, and y equals to sine pi by 6 plus pi by 6, because it is sine t plus pi by 6. So pi by 6 is 30 degree. 30 degree plus 30 degree is 60 degree. Sine 60 degrees is square root of 3 by 2. So the point is half square root of 3 by 2. So now the equation of the tangent. So y minus y1, which is square root of 3 by 2, equals to gradient is 1 by square root of 3. X minus x1 is half. So the equation was, find the equation of the tangent, and we don't have to answer in any particular format, so we can just keep the answer in any way we want. So y minus square root of 3 by 2 is 1 by square root of 3x minus 1 by square root of 3 into 1 by 2 is 1 by 2 square root of 3. We can write y equals to 1 by square root of 3x minus 1 by 2 square root of 3 plus square root of 3 by 2. It doesn't really matter at all. We can just leave the answer in this format. The next question is, we have to convert this into the Cartesian equation. So show that the Cartesian equation can be expressed as this. The first thing that we have to do, x equals to sine t and y equals to sine t plus pi by 6. So in order to connect the two, the first thing that we have to do is we have to have an identity that connects these two. Before doing that, we can break this down into the sum of angle identity sine a plus b, which is sine a cos b plus cos a sine b. So we can just write sine t cos pi by 6 plus cos t sine pi by 6. So sine t cos pi by 6 means cos 30 degree. Cos 30 degree is adjacent by hypotenuse, so this would be square root of 3 by 2 plus cos t sine pi by 6. Sine pi by 6 means sine 30 degree, which is opposite by hypotenuse, which means half. So sine t is the same as x, so we can write root 3 by 2 x, because sine t equals to x, plus half. Now what is cos t? Now if you think about this, cos squared theta is 1 minus sine squared theta. So therefore, if I send the square to the other side as a square root, I can write square root of 1 minus sine squared theta. So by that logic, we can write, instead of cos t, we can write square root of 1 minus sine square t. So sine t is x, so sine squared t is 1 minus x squared. So that's what we can write. So if you check root 3 by 2x plus half square root of 1 minus x squared. So that's the Cartesian equation. This particular question we have to find the equation of the tangent again. If you notice, all the sum that we're doing, it's like the C1 sums. In the C1 sums we have to find the equation of a tangent to the curve or equation of the normal to the curve. So although this is a C4 question, we are using the concept of C1 for doing these C4 parametric equations. We have to find the equation of a tangent. So we need, first of all, let me write it out like this. So if y equals to 1 minus t to the power minus 1, so I'm bringing this upstairs. So therefore dy by dt, by the algebra rule, the power comes first, then I write the whole thing by decreasing the power by 1, so that will be minus 2, and chain rule. So remember, you might think this is 1, so you might avoid this, but no, this is the derivative of 1 minus t is minus 1, so by the chain rule we have to write minus 1. So minus into minus is plus, so 1 by 1 minus t whole square is the derivative. Again with x, if I put 1 plus t upstairs, it would be 1 plus t to the power minus 1. Therefore the derivative dx by dt, by the algebraic rule, the power will come first, then I'll write the whole thing by decreasing the power by 1, that would be minus 2, and the chain rule of 1 plus t derivative is going to be 1. So this would be minus 1 by 1 plus t whole squared. So we have the derivative of x and the derivative of y. So dy by dx would be dy by dt, which is 1 by 1 minus t whole squared, divided by dx by dt, it is minus 1 by 1 plus t whole squared. So that makes minus 1 by 1 minus t whole squared into 1 plus t whole squared. So this is the expression for the gradient. We have to find the gradient at the point t equals to half. At t equals to half, dy by dx is minus 1 by, so 1 minus half whole squared and 1 plus half whole squared. So 1 minus half is half, so this is half squared. 1 plus half, 2 ones are 2, plus 1 3, this is 3 by 2 whole squared. This is minus 1, so 1 by 2 whole squared is 1 by 4, and this is 9 by 4. So that means, so the gradient is going to be 9 by 16. I think there has been a mistake here. Okay, I found this mistake. This one should not be this, it should be 1 by 1 minus t whole squared into 1 plus t whole squared divided by minus 1. So it's, when you divide, you just reverse the multiplication, so it should be 1 plus t whole squared divided by minus 1 minus t whole squared. Okay, this is a common mistake, so let me correct this. So this would be at t equals to half, 1 plus half whole squared divided by 1 minus half whole squared. There is a minus here, so 1 plus half is 3 by 2, so 3 by 2 whole squared. 1 minus half is half whole squared, and there is a minus here, so this would be 9 by 4 divided by minus 1 by 4, so this would be minus 9. So gradient of tangent equals to minus 9. We need to find the point now. At t equals to half, x equals to, x equals to 1 by 1 plus t, 1 by 1 plus half, that means 1 by 3 by 2, that means reciprocal is 2 by 3, and y equals to 1 by 1 minus t, which is 1 minus half, which is 1 by half, 1 minus half is half, which is 2. So the point is 2 by 3 and 2. Now we can find the equation. So the equation is y minus y1 equals to m, the gradient is minus 9, x minus 2 by 3. Y minus 2 equals to minus 9x, minus into minus is plus, 3 3 is a 9, 3 2 is a 6. Y equals to minus 9x plus 8. The final question, we have to convert this into the Cartesian equation and show that this is the case. Since this is algebra, this is not trigonometry, so this would be pretty straightforward to do. So x equals to 1 by 1 plus t, so if we cross multiply, 1 plus t would be 1 by x, so therefore we can say t equals to 1 by x minus 1. It's a good idea to simplify this now. So x1 is x minus 1 into x is x, so t equals to this. So now we can put this in the next equation. So y equals to 1 by 1 minus t, and t is, second thought, I think this version is better. So 1 by x minus 1. So 1 by 1 minus 1 by x plus 1. That makes it 1 by 1 plus 1 2 minus 1 by x. So if we take the LCM here, x is the LCM, 2 into x is twice x, minus x1 is a x. So do the sum here. Okay, so y equals to 1 by 2x minus 1 divided by x. If I do the reciprocal, it would be x divided by 2x minus 1. I think this is it. So y equals to x by 2x minus 1. So that's the Cartesian equation. The first thing that we have to do here is to find the value of t when x equals to 2.5. So when x equals to 2.5, 2.5 means 2 to the 4, 4 plus 1 is 5 by 2. So when x equals to 5 by 2, all we have to do is put it here. So 5 by 2 equals to t plus 1 by t. So we can multiply both sides with t. It would be 5 by 2 into t equals to t square plus 1 by t into t is 1. Now we can multiply both sides with 2 to simplify the algebra. So 5t equals to 2t square plus 2. So we can have a quadratic equation 2t square. If I bring this 5t to this side, it would be minus 5t plus 2 equals to 0. I'm actually bringing this to this side and just reversing the order, that's all. Now middle term break. It's a quadratic equation, so we have to find two values of t. So 2 to the 4, and we can get 5 by 4 ones are 4. So 2t square minus 4t minus t plus 2 equals to 0. If I take 2t common, it would be t minus 2. If I take 1 common, it would be t minus 2 equals to 0. So this would be t minus 2, and this would be 2t minus 1 equals to 0. Therefore t equals to 2 or t equals to half. So we found two values of t. The next thing that we have to do, find the gradient of the curve at each of these points. So when you have this, so this is what's happening. So 2.5 is somewhere like this. This is the line. So 2.5, this is the line. Let me draw it properly. So 2.5, this is the line, and it's cutting the curve at this point and this point. So what we did here, when we put the value of x here, so we just found the values of t here and the values of t here, like a limit. Now the next thing we have to do, find the gradient of the curve at each of these points. So at this point we have to find the gradient, at this point we have to find the gradient. For gradient we need the expression, so dy by dt. So dy by dt is going to be t minus 1 means 1, and dx by dt, derivative of t is 1, and 1 by t means t to the power minus 1, that means minus t to the power minus 2. So 1 by 1 minus t square. So the expression, so dy by dt would be dy by dx would be dy by dt divided by 1 minus 1 by t squared. So first at the point t equals to 2, so we have two values of t equals to 2 and t equals to half. So at t equals to 2 we have dy by dx 1 by 1 minus 1 by 2 squared. This would be 1 by 1 minus 1 by 4. So 1 by 1 minus 4 means 3 by 4. So this would be 4 by 3. At t equals to half we get dy by dx equals to 1 by 1 minus 1 by t squared means 1 by half squared. So 1 by 1 minus 1 by half squared means 1 by 1 by 4. So it means 1 by 1 minus 1 by 1 by 4 is a reciprocal, it will be 1 by 4, so this will be 1 by minus 3. So at t equals to half the gradient is minus 1 by 3. Now that we have found the gradient at the 2 points, we have to find the area of the finite region. The area that we have to look for is this region. Find the area of the finite region enclosed between the curve and the line x equals to half. So this line is x equals to 2.5. So this is the region we are looking for. So for finding the region like this, what we have to do, we first have to find the area from this point to this point. So if we integrate from this point to this point, we can actually find the area, then we can multiply by 2. But we already know the limit from here to here. So since we know the limit of t, so we can just integrate the area in terms of t. So the Cartesian integration is going to be a little bit of a review. So the C2 rule says that if you have a rectangle, suppose this is the length and this is the breadth, the area is going to be L into B. Now this is a curve and it has a limit starting from here and ending here. It is made up of many rectangles. So the area of this region is given by integration of the limit starting at A, ending at B, and having a rectangle. The rectangle is length is y, so this vertical is y, and this breadth is dx. That means you add up all the rectangles. In other words, area is integration of limit a to b y dx. So this is the y and this is the dx. This is the idea behind the area. So getting back, so what we have to do here in question number C is we have to find the area. So the area would be given by the integration, the limit is Cartesian, x1 to x0, x1 to x2, y dx. So that's the area, but this is a parametric equations. For that particular reason, we have to convert this using substitution. So here we have to do integration by substitution. So integration by substitution means when we have a Cartesian integration a to b y dx, we have to convert that Cartesian into parametric by converting the limit t1 to t2, converting y in terms of t, and then converting dx as dt. So this is how we have to convert. So the idea is converting the Cartesian integration into the parametric integration. For this particular sum, we have already the values of t for the limit, so we don't have to worry about the limit. So we know, so for the limits, we know t equals to half and t equals to 2, so the limit will be from half to 2. And we also know we know x equals to t minus 1 by t, so therefore dx by dt is 1 minus t to the power minus 2, that means 1 minus 1 by t square. Therefore dx equals to 1 minus 1 by t squared dt. So this is, we already know this. So when we do the substitution, if we can simply write hence area equals to, so the limit x1 to x2 is going to be t equals to half to 2. Y, we know the expression y is t minus 1. So t minus 1, and dx is equals to 1 minus 1 by t squared, 1 minus 1 by t squared dt. So this is, we have completely used substitution to convert this Cartesian integral into this parametric integral. Now we simplify, so half to 2, so if you multiply t into 1 it's t, minus if you multiply t into 1 by t square it is 1 by t, minus 1 into 1 is minus 1, minus 1 into minus this is plus 1 by t square, and we have dt. We can write half to 2, so this is t minus 1 by t minus 1, plus we can take this upstairs, t to the power minus 2. Now we can integrate. Integration of t is t squared by 2 minus integration of 1 by t. Reciprocal of a linear is logarithm, so ln t divided by chain rule, derivative of t is 1, minus integration of 1 is t, plus t to the power minus 2 is going to be t to the power minus 1 divided by minus 1. This is ax plus b to the power n. So, and the limit is half to 2. Now we try to simplify this. We can write t squared by 2 minus ln t minus t minus 1 by t. So limit is half to 2. So let's put the value of 2 first. So this would be 2 squared by 2 minus ln 2 minus 2 minus 1 by 2. Now we can put the limit of half. Half square by 2 minus ln half minus half minus 1 by half. So this would be 4 by 2 is 2 minus ln 2 minus 2 minus half. So this 2 and this 2 cancels, minus 1 by 4 divided by 2 is 1 by 8. No, 1 by 4 divided, yes, it's 1 by 8, minus, if I bring this 2 upstairs it will be ln 2 to the power minus 2, ln 2 to the power minus 1. If I bring this upstairs, so minus 1 by 2 minus 1 by 1 by 2 is 2. So this would be minus ln 2 minus half minus, now this is 1 by 8. This, if I bring this minus in front, this would be plus ln 2, this would be minus, this would be minus 2. So if I remove the bracket, minus ln 2 minus half minus 1 by 8 minus ln 2 plus half plus 2. So minus ln 2 is minus 2 ln 2, minus half plus half cancels, so 2 minus 1 by 8 is going to be 2 minus 1 by 8 is going to be 15 by 8, so 15 by 8. Now the answer is supposed to be in exact form or decimal. Find the area of the finite triangle. They didn't mention, so this is the sum.